Hello everyone, this is Miss Williams, and this is our very first flip video. It shouldn't take too long, and we've actually done some of this in class, so you'll just need to finish the worksheet we've already started. So this is going to be parent functions and transformations day 1. Alright, we're going to start with the definition of the parent function. Parent functions are the most basic functions in a family of functions. Okay, so we will review 7 different parent functions, and you will be responsible for knowing 3 things about each parent function. You need to know the name of it, you need to know the equation for it, and you need to know the graph of it. So we're going to go through those 7, and it really doesn't matter which order you put them in. So if your paper is in a different order because we started different orders in different classes, it's fine. But make sure somewhere on your paper you have a constant function. A constant function is where y equals a, and a can be any number. So if you were to make a t-chart, so you could figure out how to graph this, it doesn't matter what you put in the x spot, y is always going to be equal to a. So if you were to graph that, it would be a horizontal line, and this a happens to be about 2.5. So that's why everywhere, all across the line, y is always equal to 2.5. So this is called a constant function. The next one that we're going to talk about is a linear function. Linear functions are probably what you first learned to graph, and those usually come in the form of y equals mx plus b. Well, remember, we're talking about the most basic function, so y equals x would be the most basic linear function. If you were to make a t-chart of that, whatever you plugged into the x spot, the y would reflect it, because y and x are the same thing. So therefore, when you graph this, it is a diagonal line that goes through the origin. Okay? If it was me, I would be writing not only the equation and graphing it and the name of it, but I would also be writing down the t-chart on my paper. Okay? Number 3 is the quadratic function. You should have studied this a little bit in Integrated Math 2 last year. So the most basic function is y equals x squared, because without an x squared, you cannot have a quadratic function. If you were to make a t-chart of this, you can plug in 0 and get 0 back out. When you plug in 1, you get 1, because 1 squared is 1. But also when you plug in -1, -1 times -1 gives you a positive 1. 2 would give you 4, and -2 would also give you 4. So you end up with a parabola, or a U-shaped graph. Number 4 is a cubic function. Cubic function is where the highest exponent is an x to the third. Now, when you did a quadratic function, you saw that everything was above the x-axis, because any time you put a negative into a square, it became a positive. Well, now when you put negatives into a cube, they actually stay negative, because 3 negatives continue to give you a negative. Okay, so the shape is going to look a little different. It kind of looks the same because it's got the curve, but instead of it curving back up and making a U, it kind of makes a squiggly little line there. Number 5, I believe, is square root. This was y equals the square root of x. That symbol is also called a radical. Okay. Now look at my t-chart. How does this look different this time? Well, 0 is still 0. 1, the square root of 1 is 1, because 1 times 1 is 1. The square root of 4 is 2. The square root of 9 is 3. But the square root of -4, I can't plug negative numbers in because we haven't covered that yet in your mathematical career. So the square root of -4 is not possible. There's no number you can multiply by itself that would give you a negative number. So when you go to graph this, it begins at the origin, and then it goes up and to the right. Alright? You'll never get down in here into the negative parts, because on the left-hand side of the graph, because you can't put negatives under the radical. Alright? So we did a quadratic, and the inverse of that is a square root, and now we're going to do cubed root. So this would be y equals the cubed root of x, because cubed, there's a little 3 up there in the power, in the root. So now, if you look back, we couldn't put negatives in square root, but we can put negatives in cubed roots, right? Because -1 times -1 times -1 does give me -1 back, as is. Same thing with -2. If you did -2 times -2 times -2, you get -8. So therefore, you can take the cubed root of negative numbers. So when you graph this, Okay, see how I'm plotting my points here? 0, 0, 1, 1, and then it's hard to plot 8, go all the way over. You'd have to go all the way over to 8 before you would get up to 2 on the y-axis. Okay, kind of goes off my screen there. And the last one we're going to talk about right now is absolute value. Alright, if you remember absolute value, the actual definition of an absolute value is its distance from 0. Because distance can never be negative, that's why whenever you take the absolute value of a number, it always ends up being a positive answer. So, it doesn't matter if we plug in positive and negative numbers, we always get positive answers back out of the y. And when you graph this, these are straight lines. It should make a V-shaped, not a U-shape. So be sure when we go to take an assessment over this that you do not mistake in your U-shape and your V-shape. Be very specific as to the shape that you're giving your graphs, okay? So we will do an activity with transformations when you come to class next, so make sure you bring your paper back with all your notes written on it. And I will see you next class.